Okay, this problem reads, use the given data to find the minimum sample size required to estimate a population proportion or percentage. So in this case, the margin of error is 0.02, confidence level 90%, and p hat and q hat are unknown. So we have a choice here. Sometimes you'll have a prior estimate of p hat, and sometimes you won't. And I'm also going to show you two different ways to do this. There is a by hand way. And when I say by hand, it is using the formula. It's one of the few that are not built into the calculator. Not sure why it's not in there. You might be able to write a little program for or find one on the internet. So here's our formula. We have n equals, make it a little bit bigger, n equals z sub alpha over 2 squared times 0.25 divided by e squared. And if you watch the videos or look at the books, you kind of see where this formula is derived from. Not super important for this particular example. So where's that z alpha over 2? Recall this is a 90% confidence interval, and we've done a lot of these before. There is a known quantity for that particular z value. So if I were to sketch that out, and I did 90%, this value here that's in the tails, the associated value there is negative 1.645. So that is our value. If you're ever unsure, you can always use the calculator or StatCrunch to figure this out. You can put in inverse norm 0.05 because remember it's 90%. So that means we have 5% left in the tails. And then the standard normal curve, so 0, 1. And if you have the choice to put left, put left. If not, it defaults to left. And you'll get negative 1.645. The critical value is always positive, so we just take the positive part of that. So we would put 1.645 squared. Now the ones in here you typically are going to have are 90 and 95 and 99%. So those come out a lot, so make sure you kind of have those at the ready. Times 0.25 divided by the margin of error, which is 0.02. Okay, and I forgot to square this little part right here. Square the 2, the error. So on the calculator, I've got 1691.266. We always round up to the next integer. Although I'll be honest, I think my math lab gives you credit if you put 1691. So the answer here is 1692. 1692, but 1691 would also work. We're only off by 1. I know if you're a math person that really can be frustrating. But again, all these are based on approximations anyway. So 1692. Technically, but I believe they give you credit for 1691. If you're off by that, let me know. Email me that, and I will. I can override that pretty easily. Let me show you how you can do this on StatCrunch. It takes a little bit of more thought, though. Let's flip over to StatCrunch. Okay, so in StatCrunch, you're going to go to Stat, Proportion Stat, One Sample, and you're going to go to Width Sample Size. We're concerned about the width and the sample size. So we have a given width, and that width is the error. So our confidence level again is 0.9. Our target, since we don't know, we don't have a prior estimate, we're going to leave that at 0.5. If you do have a prior estimate, you just put the prior estimate in this target proportion. Okay. Our width is, so our margin of error is 0.02. So the whole width of that is 0.04. That's a part I could see you missing. I could see me missing that. I don't use this tool a whole lot. And we get 1691. Now you notice it ticked it down a little bit, so it'd be nice if that had kept it at 0.04, and if the applet had went ahead and rounded it up, but it doesn't. So 0.039999582 is 1691. So I hope that helps.